So this question said the point of inflection of the function f of s equals to 2s cubed minus 3s squared plus 2 is dash. So step 1. Actually, point of inflection is a point where the function starts decreasing or increasing. Yeah, if you have a function when it starts decreasing or decreasing, that's what we call point of inflection. But we're not here for the minutia, just listen to how this is being solved. Now, for we to have a point of inflection, we need to consider the first derivative and second derivative, and most importantly, the second derivative. We'll use the value we get in the first derivative and test them in the second derivative. After testing them, we'll know whether it is whether it has point of inflection or not, and if it has, what are they? Okay, now the first thing is to pick the function the way it is. F of x is equals to 2x cubed minus 3x squared plus 2. We'll find first derivative, which is what? That's step 2 now. Find the first, that's f prime of x, first derivative, which means f prime of x equals to 3 will come to the front, 3 times 2 x, remove 1 from the 3, we have 2, minus 2 will come to the front in this one, times 3x, remove 1 from 2, you have 1, then plus 0, a constant, and this equals to 3 times 2 is what? 6x squared minus 6x. So we'll solve this equation. Yeah, that's the next step now. The next step, we'll solve it to get what we call the critical points. So step 3, find the critical points. So to find those critical points is to solve this f prime of x when equated to 0. 6s squared minus 6s equals to 0. 6s can come out. We have x minus 6 equals to 3 minus 1. When 6s comes out, you have 6s out here, you have only s left. 6s out here, you have just 1. So that means 6s divided 6s is 1. That's what I just meant. So this 6s is either equals to 0 or s minus 1 is equals to 0. So s is equals to 0 over 6 or s is equals to 1 when minus 1 cross the other side. So s equals to 0 or 1. So we go and we test them using the function we have. We test them in the second derivative. Yeah, second derivative. So step 4. Step 4, find second derivative f prime prime of x, and this will mean f prime prime of x equals to second derivative. Now you differentiate this in again second time. 2 goes to the front, you have 2 times 6, that's what? 12x. Remove 1 from the 2, that's 1, so that's just x now. Minus 6 when you apply the same thing there. So at s equals to 0, we'll find our f prime prime. F prime prime of 0 equals to 12 bracket 0 minus 6, and that's equals to minus 6. F prime prime of 1 now is equals to 12 bracket 1 minus 6, and that's equals to 6. So you see that the signs are not the same, this minus and this plus. Therefore, 0 and 1 are points of what? Inflection. Because their signs are different. They mustn't necessarily be the same number. But since their signs are different, this is minus and this is plus 6. So we say that we have point of inflection at 0 and 1. Or we can still say that assuming we solve and get 0. That's whenever sometimes you solve this s and get just one number. If you put that one number inside the derivative, just one number, you will be getting 0. It's also a point of inflection. So it's either you're getting two different two numbers with 2 different signs, or you're getting just a function of the second derivative as 0. That gives you the point of what? Inflection. So number 1, I repeat again, if second derivative is 0, it's a point of inflection. If the second derivative happen that it changes sign as you do 2 of them, assuming you get 2 answers, those 2 numbers are also point of what? Inflections. So that's how it is being solved.